Hi, Assalamualaikum warahmatullahi wabarakatuh. We meet again in another topic, still in topic number 1, introduction. But now we will look at on OS function and component. There are total 7 OS function and component that we will go through. Number 1 is user interface. Number 2 is as CPU manager. Number 3 as memory manager. Number 4 as network manager. Number 5 as path manager. Number 6 as IO or device manager. And last but not least as IPC or inter-process communication manager. Alright, we will look at on every topic, every function here. Not very detailed because we go through in details in the next topic. Alright, we have topic, individual topic for each component. Alright, so now, alright, first we look at on what we call OS command and OS command interface. Yeah, okay. There are two types of command interface. Type number 1 is CLI, we call as command line interface. Command line interface, which is here example in DOS environment, 100% command line interface. In Linux, for example, or Unix, we have also command line interface. Right? User has to write command. Is a type of command. Command must be remembered a line at a time. And some command use unique, such as we will learn about this command later on. Alright, in the lab actually we have all type of command. Like for example, for Linux or Unix is the same. We have cd, cp for copy, list for list, ls for list, and it different a bit with MS DOS, dir, copy, and md. And about CLI. How about the input devices used for command line? Of course, command line only depends on keyboard. This keyboard, okay? So we need to write a command using keyboard only. We don't have mouse. It's different with graphical base. Graphical base like Windows, we have very good graphical, right? Like Windows, like Mac. Which allow user to easy to understand to activate operating system command by clicking on desktop icon or menus using a mouse or pointing device. And we also have keyboard. We not only depend 100% on keyboard. That is about command interface. Number 2 is processor manager. In processor manager will decide, alright, who will get the access to the CPU. Alright, for example, in multi-environment, multi-user environment, or in multitasking environment, we have multiple programs running at the same time. But here, processor manager responsible to select which process to be executed by processor, who get the access based on priority order. Right, so this is we call as scheduling. Processor manager have scheduling to keep the track, to keep executing. You have the schedule, or you have the schedule which process to be executed first, second, and so on. Alright, so that is about processor manager. Rather than that, processor manager also have to indicate the status of the process. Either the status of the process is used, new, waiting, completed, and so on. Alright, so processor manager also monitor the CPU to either read or write command to finish the execution. Example, it will read command from the IO, write command to the IO. Alright, processor manager has two responsibilities. Alright, one is to handle the job as they enter the system, and the other one is to manage its process within this job. Alright, so then this is about processor manager. Alright, so how about memory manager? Alright, memory manager is actually 100% in charge in main memory, or we call as physical memory, or we call as RAM. So the manager who were responsible for this management of memory. Alright, in memory manager also we will learn about virtual memory, how we use extra memory from the hard disk to expand for the what we call for the to expand the size of the memory, or to expand the capability to get more memory or get more process to be open. Alright, in memory manager also we have here to indicate or to validate each request for memory space, and if used or not used. Alright, so then a lot of things we will learn about memory manager. Okay, so this is another topic in memory management. So next is networking manager. Alright, in networking manager, which is provide convenience way for the user to share resources while controlling user access to them. These resources include hardware such as CPU, memory area, printer, tape, drive, modem, and disk drive. Alright, next is I/O device manager. The device manager will monitor every device. We will see in device manager topic, management topic in both environment, Linux and Windows. For example, in Windows, we have device manager will allocate a device, make it available to the next process on job. Alright, it's the same goes to the Linux I/O manager or device manager. They have the mechanism, they have the way to check the status, allocating devices and so on. Alright, so I/O device module keep track of the status of device. Either device is busy, free, being used, or any status. Alright, so next is path manager. Path manager will keep track of every file in the system, including data file, program file, compiler, and also application program. The path manager also control what others are allowed to do, and when will allow who can access the file, and who can access and what we can do for that particular file. Alright, by using the protection mechanism. Alright, so that is in path manager. And last is cooperation issue. Each manager that I explained previously, six manager, they cannot work separately. They need to work in cooperation with this kind of another manager. So that's why we need IPC, or interprocess communication, or we call as cooperation. Alright, so they will this IPC will help in terms of interprocess communication to make sure that all these managers can work in good ways. Will work in, how to say, they will work in cooperation each other. So all the device, all the manager need each other. Alright, so example, alright, to do the printing, example here we want to do the printing from the example, we want to do the printing for the pen drive, for example. So user plug in the pen drive, and then we can see there are few managers working together to make sure that at the end of the result we will get assignment or any work to be printing. Alright, so that is all we call as cooperation issue. So this always being asked in final question. I remember it's second 2 times already. Alright, so that is about cooperation issue. Alright, so I don't want to look at every step here. You guys have to understand every step here. Alright, so this example is let's say someone type of command to execute a program. Alright, just now I give you an example of printing document from pen drive. Okay. So alright, so next topic about characteristic of modern OS. We have 4 types of characteristic. Alright, first is what we call microkernel architecture. Microkernel architecture is quite really different with monolithic kernel. Monolithic kernel is based operating system, is all version of operating system. And now we have what we call microkernel based operating system. What is the difference between these two architecture is, in microkernel, in monolithic kernel, so everything, most of the services inside the kernel mode. But in microkernel, some in kernel mode we make it in user mode. Alright, so we look at here. Alright, so for example here, okay, we have in monolithic kernel, we have VFS, IPC, file system, scheduler, virtual memory, device driver, and dispatcher inside kernel mode. Alright, now In microkernel, we move some of the component which is not suitable inside kernel mode to the user mode. For example, now we have IPC now in user mode. We have device driver, we have unit server, file server, everything in user mode except basic IPC, visual memory, and schedule is still in kernel mode. Right? So this is about microkernel. Then we look at what is the benefit, what is the good thing about having microkernel compared to monolithic. Right? So microkernel is not new. It developed in 1980 when the first LAN being introduced. Alright, the main function is, first of the benefit is new services which is add to the user space. We do not need to require modify the whole kernel. Alright, and of course it more secure and reliable. It being commonly being used in embedded segment. Okay, so OS service will be implemented as user space program to allow them to be worked on monolithically and started and stopped like any other program. Alright, that is why some services we put in user space so that it can be open and start and stop like any other program. Alright, so this is another benefit of microkernel. Microkernel allow the addition of new services again without requiring of modification new kernel. Number B, Modular Design impose a uniform interface on requests made by a process. It's more flexible, it's more secure and flexible because features we can be subtracted, kita boleh buang ataupun can be added without compile the new kernel. Alright. Modular design help to enhance stability, and the microkernel support distributed OS and object-oriented programming. Alright, so seterusnya is number 2 is multithreading. Multithreading is not new actually because this actually used for many operating system, used in many computer. Alright, in multithreading we should understand about the difference between thread, different about process and application. This always been asked in final question too. What is a thread? What is a compact thread with the process? Thread, you can remember this thing. Thread is lightweight. Apa maksud lightweight? Alright. So lightweight means here is ada kat sini. Alright. Lightweight means that it share memory. A thread is lightweight because it share the memory among the thread. Alright. Maksudnya thread yang sama working together will have the capability untuk share the memory. It's different with the process. Process tak boleh share memory because each process have their own space of memory. Alright, that is a thing. That is the biggest comparison, biggest difference between thread and process. Thread is lightweight because it can share memory. Remember, process is not lightweight because each process have their own space memory. What is the difference again? One process can create more than one thread. One application can create more than one process. Alright, so ada tak lah kat sini? Alright, this thing you kena faham betul-betul the difference between application, process dan juga thread. Alright, like process dan application, for example. What is application? Application is what we call inactive entity, di mana application tak akan aktif. Once it active, we call as process. Application is a program installed in computer, while processes, when we user click or open that program or the application, that is we call process. Process is an active entity. Alright, again, the difference between process and thread is what I explained previously. Alright, so now we look at on SMP. Alright, SMP is a computer architecture which is provide fast performance by making multiple CPU available to complete individual process. There are two types of multiprocessing. One is SMP, another one we call as AMP. SMP is something like senang nak ingat adalah apa yang penting kerja sama. So every processor will complete each other. Maksudnya one process, maybe we example we have one process. This process is gaming process. Alright, this gaming process will create more thread. This thread will be divided, will be divided by each processor. Each processor will get one thread for that particular thread, that particular process gaming tadi. So each processor, let's say we have a multi-core environment, we have 4 processor. Keempat-empat processor ini akan saling membantu untuk complete the task for gaming. Alright, there is no chance to get one processor free, because one free they will get another job. Alright, that is in SMP. It's different with AMP. AMP here is we use in segment, like for example in embedded segment in real-time application. What actually AMP use, AMP use one what we call one process execute by one processor. For example, we open multitasking environment, we open multiple application at one time. We open Word document, game, we open FB, we open apa lagi, video. We have 4 application running at the same time, and we have 4 processor running. Alright, so each processor have one process to be conduct. For example, processor 0 use a gaming, processor 2 use for Word, processor 3 use for FB, and so on. Alright, so what is the different? What is the result here? In AMP, workload not balanced, because we know that some application may be heavy workload, like gaming compared to Word document, it may be more workload. So this CPU 0 who work on gaming will 100% use, will be very very busy, while the processor who actually handle the process for Word document may be free. That is what we call workload not balanced. This AMP only used in different application, only in different segment, maybe in real-time application or embedded. But the best or the fast performance is of course go for SMP, and most of us use SMP approach because we want to reduce this what we call workload not balanced. In SMP, workload is balanced. Everyone is doing job, so no one will free, no one will be suffer. Everyone will working together to complete the task. That is SMP. Alright, and last we have object oriented. So object oriented, why we use object oriented concept in a kernel. So kernel reside memory. You know what? Kernel is important. It's important. We call as brain or operating system is very important. It must be reside in memory. So when we turn on a computer, this kernel must berada dalam RAM. There is space for kernel. Alright. So not dalam object oriented, we should know that not every memory, not every process should be in memory. Only important thing must be in memory, the rest in hard disk. Alright, what we call kernel reorganization here, memory resident, again, only for a few essential functions such as process, kernel, and memory allocation must be in memory. Module, all other functions seperti device allocation are not allowed reside in the memory at all time. Again, only important functions sahaja yang will be allowed reside in memory, the rest will be in hard disk. And process swap in and swap will be very frequent between the hard disk and the memory. Why we need to do this? Because we know that memory kita tak banyak. So memory kita very kita panggil apa? Very just memang must be fully utilized, must be really used for important thing only, so that we can open multiple process at one time. So advantages is modification and customization without destroying integrity of the remainder of the system, so that software development can be more productive. Alright, so itu adalah about characteristic of modern OS. Alright, so here this is early OS, everything inside memory. So we need more. Alright, we need more space for OS, for example. But while having object-oriented OS implemented in memory, implemented in operating system, so you can see here we need small space of memory for OS. The rest inside the hard disk. You see the difference? Alright, not every function should be in memory. Alright, or another function should be in the hard disk. This we call as hard disk. Alright, ada lagi tak? Okay, that's it for the topic for the function and also modern characteristic. I will continue on the next topic, still in topic number 1, which is OS booting concept. That's it from me, from Madam Mazia. I hope that everyone enjoy my class. So if you got any question, you can always ask me during our class, during our online class. So this video for you guys to learn more, keep more learning, and then we will discuss more in our class. Okay, till we meet again. Okay, bye.